All right, welcome everyone again to a new segment of Finals Countdown, which is for this semester, actually spring 2021. Again, my name is Kwane Yazi. My dish gazing the Shlin Nash Edge the Nabashchin, but that Nash Chedo, the best legend national. I am originally from Rock Point, Arizona. So yeah, I'm also one of the professional writing tutors here at the Net College. So I'm actually under the Taylor campus. So as we've been progressing through Finals Countdown, right? I think this is like our 8th or 9th event so far of Finals Countdown. So today we actually have Roberta from the Shiprock campus who will be going over polynomials for Math 100, I believe, yeah. And then later on today, the one for 11 o'clock is actually going to be postponed or recorded to be posted onto YouTube. And then at 1 o'clock, we have another segment of Math 102, I believe is on decimals and percentages. And then at 3 o'clock, I'll be going over transitions for coherence, which is basically looking at how you can transition through your essays and how can you organize information and stuff like that. So we'll go ahead and get started. Again, at the very end of this session, we'll go ahead and have the evaluations form posted by me. I'll be posting it this time. And then, yeah, we'll go from there. Go ahead, Roberta.
Good morning. My name is Roberta Ayu of the Shiprock Learning Center. Senajili Nishlet Ado na Kinthachitni Bashes Chain, na Kaidina Dashiche and Tachitni Dashanella. Today I'm going to be covering polynomials. Polynomials. We're going to cover adding and subtracting polynomials, multiplying polynomials, factoring polynomials, and going over the FOIL method. You'll notice at the bottom of majority of my slides will tell you to remember to always watch your signs as you are distributing, multiplying, and combining throughout your functions. Polynomials, just basic information about polynomials. It can be a single term or a sum of two or more terms containing variables with exponents that are whole numbers. And they are always, it is better to solve them in the order of descending powers of the variables, which is called in the standard form of ax squared plus bx plus c. And then simplified polynomials are also known as monomials, binomials, and trinomials. As you can tell by the words, mono means one, bi means two, and tri means three. In this section, we're going to be covering adding and subtracting polynomials, and it'll be done with combining like terms. Adding polynomials. You are combining like terms by adding just the coefficients. Remember that the terms must same variables with the same exponents, and you arrange them like terms in. You can also solve them by arranging them in like terms in columns and combine vertically, such as the example on this side. When you add polynomials, you can stack them like this: x squared minus 5x minus x plus 5, and you can put the 6x squared plus 2x minus 10 underneath it, and then just solve vertically downward. As you can tell, 5 minus 10, there is no variable or no term variables on it, so you can combine the two. And then the negative x and the plus 2x, because the x are single, you combine those two, and then the x squares are in line with each other, and you can combine the two. In this one, we're be subtracting polynomials. It is just like solving the addition one. It's the same concept. You can stack them up vertically and combine. As in this example, the 3x squared minus 8x plus 7, subtracting the 2x squared minus 6x plus 12. You can add an addition sign. Make sure you distribute your negative sign throughout the whole function. As in this example up here, the minus became a negative 2x. The negative and a negative became a positive 6x, and then the negative and the positive 12 became a negative 12. And then you can stack them up and then add them together. In this slide here, it's just a little, I called it a self-check. So you can, it is throughout each section of my presentation. It is just to help you to know that you can answer the questions. I can add polynomials. Can you do it confidently, like with no help, or you can do it right off. You can also see if you need more help. And if you don't get it, then you can ask for more help. And we are here as tutors to help you in this, and having a self-check after every section of your math is very great, because then you know that you have to work on that and you'll be able to know what you need help on. In this section, we'll be talking about multiplying polynomials. There's a distributive property and the FOIL method. Multiplying monomial by monomial, the product of two monomials. Use properties of exponents. Recall, when multiplying two exponential expressions with the same base, you just add the exponents. As in this example, a negative 8x to the 6th times 5x to the 3rd. Your coefficients, negative 8 times 5. You carry your base of x over, and you just add your exponents, 6 plus 3. And you will get negative 40x to the 9th. And to always remember to watch your signs as you're multiplying. Distributive property. This is used to multiply polynomial by monomial, a binomial by a binomial, and a polynomial by a polynomial. In this distributive property, we'll be looking at multiplying a trinomial by a monomial. Distribute the monomial to each term of the trinomial. So this 3x, you have to carry it through each term of the trinomial. So 3x times x squared, 3x times your 2x, and your 3x times your 1. And your answer will be 3x to the 3rd plus 6x squared plus 3x. In this distributive property, we'll be multiplying a binomial by a binomial. You will distribute the binomial to each term of the polynomial, and you can distribute again to each term, and you can combine like terms. We will be distributing the y plus 8 to each term of y plus 5, that binomial. So y times y plus 8 plus 5 times y plus 8. You will distribute the y to each of the y plus 8, and then the 5 to the 8, y plus 8. And we get y squared plus 8y plus 5y plus 40. And we will combine like terms, and the like terms combining is the 8y plus 5y, which will be 13y. in this example is the binomial by the trinomial. Distribute the first term of the binomial to each term of your trinomial. So 2x, you'll distribute it throughout this entire trinomial of 2x squared plus x minus 4. Then your second step will be to distribute the second term of the binomial to each term of the trinomial, which will be the negative 3, distribute to 2x squared plus x minus 4. And then you will combine all the like terms and you will simplify. So 4x to the third plus x, 2x squared minus x minus 6x squared minus 3 plus 12. 4x3 is alone. There's no other one in the, and 2x squared minus 6x squared, we'll combine that and they'll become negative 4x squared. We have a negative 8x minus 3x, combine those two and we get a negative 11x, and then we just carry down the 12. FOIL method. This is when you're multiplying a binomial by a binomial. In the FOIL method, F means to multiply the first term of each binomial. So 3x plus 5 squared is the first binomial. Your second binomial is the 2y minus 1. For F, we will be combining 3x and 2y. O means to multiply the outer terms of each binomial, which will be 3x times minus 1 or negative 1. I is to multiply the inner terms of the binomial. It's the terms that are closest to each other. Just 5y squared times 2y. L is to multiply the last terms of each binomial. 5y squared times negative 1. And then you combine like terms. In this example, we do not have like terms because we're using both x and y as our variables. Xy minus 3x plus 10y to the third minus 5y squared. Always remember your signs. You have a positive here and you have a negative here. So always remember to pay attention to your signs as you're doing this. We're going to do a compare of the two types of multiplying polynomials. There's the distributive property and the FOIL method. With the distributive, it is good to use your polynomial and your polynomial by a binomial. Binomial and binomial can be used with a distributive property or a FOIL method. It is usually preferred more with the FOIL method because it's easier to follow the steps of the FOIL. Then you have your polynomial by your binomial is usually good with your distributive. Oops. In this slide, we'll be covering the multiplying polynomials. For functions f of x and g of x, then it becomes f times g of x, which will be just your first function of f of x times your g of x. You will substitute f of x and g of x. In this example, f of x is x plus 2 and g of x is x squared minus 3x minus 4. We're going to do the f of x times the g of x. So we're going to substitute f of x and g of x. So f of x is x plus 2 and your g of x is your x squared minus 3x minus 4. and then you will just multiply your polynomials. In this example, I chose the distributive property. I separated the x plus 2 on, and then I distributed the x squared minus 3x minus 4 to multiply with the x and the plus 2. And then just went through of each term of the polynomials to distribute, and then combined the terms. And my answer at the end was x squared minus 2x minus 10x minus 8. Multiplying special products. In this, you would need to find, it's easier if you find a pattern. And there's several patterns. There's the binomial square pattern, the sum and difference of two terms, and the sum difference of two cubes. Here are the steps for the binomial squares pattern. If A and B are real numbers, to square the binomial, you square the first term and you square the last term. And then you just double the product of the two first and last terms. And the product of this should become a trinomial, which is an a squared plus 2ab plus b squared. The inner and outer terms with the FOIL are the same. So you notice the pattern of the middle term. The middle term is twice the product of the binomial's first and last terms. If you're going a and b, a plus b squared, then your middle term will be plus 2ab. That's your pattern of the binomial a plus b squared. For the negative, for a minus b squared, the middle term will be a negative 2ab. As you would notice, in a minus b squared, the last term is a negative b, which will give your answer, the middle term of your a minus b squared, a negative 2ab as your middle term. The sum and difference of two terms. This is the two terms. If a and b are real numbers, you multiply the conjugates. The conjugates are a plus b and a minus b. You square the first term, which is a squared, and you square the last term, b squared, and write it as a difference of two terms. Here I worked it out for you in the FOIL method, which is like your a squared, the outer terms, negative ab, your inner terms plus ab, and then your last term will be a negative b squared. The middle terms go away because they're subtracting from each other, and you're left with a squared minus b squared. This is the sum or difference of two cubes. We're going to be looking at a cube plus b cube, which is just a plus b times a squared minus ab plus b squared. And then there's an a cube minus b cube, which is a minus b, a squared plus ab plus plus b squared. Here's an example of how to solve or multiply, factor it out. You have 125x cubed minus 8. I took the factors of 125. which is 5 times 5 times 5. And then your factors of 8. 2 times 2 times 2. I took the first 5 and the first 2 and put it in for your a minus b. 5x cubed minus 2 cubed. Which will give you, which is like, I guess the factored out of the 125x cubed minus 8. So you take 1 5 out and you make it 5x minus 2 times 5x squared, because when you FOIL or when you distribute this out, the 5x squared times your 5x should give you 125, or it should give you the x squared times the x should give you an x cubed right off the bat. And then you'll, as we're following this formula over here, the plus ab will be your 5x times 2, and then your b squared will be your 2 squared. And we will collect like terms down here or simplify it down. You get 5x minus 2, 25x squared plus 10x plus 4. Here's the self-check for this section. Can you multiply polynomial by a monomial, multiply a binomial by a binomial, multiply a polynomial by a polynomial? I can multiply special terms and multiply polynomial functions. In this section, we'll be covering factoring polynomials, be covering the greatest common factor, factoring by groups, factoring trinomials, difference of 2 squares, perfect square trinomials, sum or difference of 2 cubes. And we can cover the general strategy of factoring and the fractional and negative exponents. Here we're going to be looking at the greatest common factor. It is an expression of the highest degree that divides each term of the polynomial. You're going to factor out the greatest common factor. Then you're going to group remaining terms together and you're going to check your work. Always remember to check your work. And then to watch your signs. In my first example, 10x cubed minus 4x squared. Here I factored out 10x cubed. There's a 2 times 5 makes 10. X squared times x makes 10 or x cubed. And then I factored out 4x squared. You got 2 times 2 makes 4, and then your x squared. My greatest common factor, what is the same out of both? I took out 2x squared, which left me with 5x and a 2. So 10x squared minus 4x squared will be 2x squared factored out of the first, and left me with a 5x minus your 2x squared and left with the 2. Factor out the 2x squared out of both of them. You get 2x squared times, and combining or regrouping the terms that are left behind, which is 5x minus 2. In this second example, it's 2x times x minus 7 plus 3x minus 7. My greatest common factor is x minus 7 because it's in the first first term and it's in the second term. Factored that out, x minus 7 times 2x plus 3. In this first example, to check your work, you distribute the 2x squared to each term. In the second example, you would check your work using the FOIL method. Factor by grouping. Some polynomials have only one greatest factor of 1. So we're going to factor by grouping the terms that have common factors. So first you're going to group the first two terms, and group the last two terms. And then you're going to factor each group, and you're going to factor out the greatest common factor. So my example is x cubed plus 5x squared minus 2x minus 10. I grouped the x cubed plus 5x squared. And then I grouped together, I added a plus sign, and then I grouped together the 2x minus 10. Out of the first group, I did my greatest common factor, which was an x squared, got that out of there, put it out on the side, and what was left was 5 plus x plus 5. And then the second group, I factored out a 2, which was my greatest common factor, and what was left behind was x plus 5. As you can tell in this one, I've done the greatest common factor out of 2 times. The first time out of the first 2 groups, and then we're going to do it again on the second, which is x plus 5 is the greatest common factor, and combined it and regrouped x squared minus 2. So don't be afraid if you have to factor out, find your first greatest common factor, and then combine everything together, and then have to find your greatest common factor again. So it's the process of simplifying your work as you go down and down the line. In this section, we'll be covering the factoring trinomials. And the standard form of that is ax squared plus bx plus c. So first, you're going to find the 2 terms with the product of ax squared. As you can see in my example or my illustration here, ax squared is the product of the first term of your binomial, and this first term of your second binomial. Your second step is to find the last 2 terms with the product of c. So here's c will be the last term of your first binomial, and then your last term of your second binomial. By trial and error, perform steps 1 and 2 until the sum of the outside product and the inside product is bx. So to find bx, it's through trial and error of adding or multiplying the outside, which is the first term of your first binomial, and the last term of your second binomial. Adding that, after you multiply those together, you add that to the product of your inside, which is you multiply the last term of your first binomial times the first term of your second binomial. You'll add those 2 together, and it should come out to your bx. If no combination exists, then the polynomial is a prime. So if ax squared plus bx plus c cannot be factored out this way, then it is a prime. And then remember to check your work. You check your work by factoring, by using the FOIL method. So as you can see, I don't know if you saw it, but it's the FOIL method in reverse. I guess like instead of multiplying these out, you're trying to figure those out as you go along, because you're starting with your trinomial instead of the two binomials. So my example is x squared plus 13x plus 40. So here, I set up my parentheses with the x's first, because I only had a coefficient of 1 on the x squared. So x squared, x and x of each binomial. And the second, I got the factors of 40, which is 1 times 40, 2 times 20, 4 times 10, and 8, or 5 times 8, which are my factors of 40. Then I added the factors of 40 together. So 1 plus 40 equals 81. That is to find the sum of the inside, the O plus I. So if I added it, if I put a 1 here and a 40 here, then I add that, it would come up to 41. So my center, my BX is 13x. I also did the sum on 2 plus 20 on my second factor of 40, came out to 22. 4 plus 10 equal to 14 on my third factor. And then my fourth factor was 5 plus 8, which came out to 13. So I put, since I have 13 here, and that's what I put in for my answer of x plus 5, x plus 8 is the answer to my trinomial. I factored it out. And you need to always remember to check your work by foiling it. Foil the x plus 5 and the 8 plus, or the x plus 8, and to see if you get this x squared plus 13x plus 40. And then always remember to watch your signs as you do this. In this slide is the factoring the difference of squares. The a squared minus b squared is equal to the a plus b and a times a minus b. My first example is 36x squared minus 25. First, I found the factors of 36, which came out to the 6 times 6. And then I found factors of 25, 5 times 5. 36 x squared minus 25 is equal to, we'll follow this pattern. Since a squared minus b squared, 36x squared is your a squared, and your 25 is your b squared. So 36x squared, the factors of that will follow this. 6x and x. And then your negative 25, your factors of 5 and 5, one of these has to be negative to get a negative 25. So plus 25, negative, or plus 5 and negative 5. The answer is 6x plus 5 times 6x minus 5. I didn't put it on here, but to always check your work, you can FOIL this out and make sure it comes out to this, because our center terms will be negative 30x plus 30x, and those two will cancel each other out, and it'll become my second example is 81x fourth minus 16. I did the same with the factors of 81 and 16. So 81 x to the fourth minus 16 is 9x squared plus 4 times 9x squared minus 4. If you see the pattern here in the negative, it looks like a squared minus b squared. We can factor this again. And I found the factors of 9, and I found the factors of 4, and I put that in there. So my overall answer for this one is a 9x squared plus 4 times 3x plus 2 times 3x minus 2. And I stated here on the side that the second example has a repeated factorization. So don't be afraid to keep factoring if you can. And you can always check this by doing your FOIL method, this distributive method. So, but to remember to always check your work. Here we're going to look at the factoring the perfect square trinomials. You have two here, your a plus b squared, which is equal to a squared plus 2ab plus b squared. And then the second one is a minus b squared equal to a squared minus 2ab plus b squared. And I have an example of that. And this one says factor using the perfect square trinomial. 16x squared minus 56x plus 49. Here I found the factors of 16, which is 4 times 4, and the factors of 49, 7 times 7. For the a squared, I put 4x and squared it because of this x squared. And then I put 7 squared because 49 is when you square 7 becomes 49. And then the center, it's a negative 2 or minus 2ab. So minus 2, my a is 4x and my b is 7. So when you multiply this out, then minus 2, 4x, 7 will equal to negative 56. So the answer for this perfect square will be a 4x minus 7 squared. Check your work by using the FOIL method. So you just double up the 4x minus 7. 4x minus 7 times 4x minus 7. You perform your FOIL method. It should come out to 16x squared minus 56x plus 49. This one is the sum or difference of two cubes. We covered this in the multiplying of polynomials, the a cubed plus b cubed, and then a cubed minus b cubed. I have 2 examples of that. The first example will be x cubed plus 1. I got the factors of the first for the x cubed, since our coefficient is 1. It'll be 1 times 1 times 1. and then the factors of the last term, 1 times 1 times 1. So I just followed the a plus b times the a squared minus ab plus b squared. So I put the x plus 1 times x squared minus x times 1 plus 1 squared. I multiplied this out and it came out to be x plus 1 times x squared minus x plus 1. You can check your work by distributing the x plus 1 out to the trinomial. And the second example is the 64x cubed minus 125. The factors of 64 are 4 times 4 times 4, and the factors of 125 is 5 times 5 times 5. Just substituted my 4 and the 5 in for the a and b. And I got 4x cubed minus 5 cubed. And I got 4x minus 5 times 4x squared plus 4x times 5 plus 5 squared. And my answer came out to be 4x minus 5, 16x squared. Combine the 4x plus 5 came to plus 20x, and squared the 5 plus 25. My next slide is the general strategy for factoring polynomials. The strategy is to 1, find your greatest, I'm sorry, I changed the letters around, it's supposed to be GCF. So the greatest common factors, factor for each of the terms and factor, or find a pattern for easier solving, or rearranging the terms and grouping your terms. So all this stuff we covered is what you're gonna be practicing as you look at your polynomial when you're factoring it. And then you're gonna check to see if factors can be factored further. So when you get past 2, you're gonna have to look at it again, make sure you factored it completely. And as you're doing this, remember to watch your signs. That we cannot stress enough, and just have maybe a Post-it sticky on your laptop screen, on your notebook paper, on your scrap paper, anywhere to remember to watch your signs. So in this example, we're going to be solving is 3x cubed minus 30x squared plus 75x. So here I factored each term. So I went 3 times x times x times x. Came out to 3 of those for the cube. 30x times x, which came out to be 3 times 10 times x. And then my last term will be 3 times 25x. Here I factored out a 3 out of each of them and 1x out of it, because that's the lowest number of your term with the lowest exponent. So I factored 3x out of 3x cubed minus 30x squared plus 25x, which came out to be x squared minus 10x plus 25. looking at your x squared minus 10x plus 25, it looked like the one of the perfect squares trinomial of a minus b squared. And we're just gonna find the factors of your first coefficient and your last coefficient. So a squared minus 2ab plus b squared is what we're going after. So a squared is x squared. Your b squared is your 25. So your 2ab is going to be 2 times 1, 2 times 1 times 5, which is equal to 10. So knowing that, your answer will be 3x times 5, x minus 5, and we square that. Looking at this, 3x times x minus 5 squared, you're going to see if you need to factor that out further. As you can see in my example, this is as far as we can go. The next slide is about the fractional and negative exponents. Although these expressions containing fractional and negative exponents are not polynomials, but they can be simplified using factoring techniques. So first you're going to find your, again, I messed up the letters, so it'll be GCF, which would be greatest common factor of the smaller exponents of the terms. In my example, I have 2 terms. So it'll be the smaller exponent of the 2 terms. And then second, we're going to be factoring. And then we're going to check to see if we need to factor further. So my example in this one is going to be x times x minus 1 to the negative 1/2 plus x minus 1 to the 1/2. My greatest common factor, as you can see, is the negative x minus 1, and the smallest exponent of the 2 will be the negative 1/2. So my greatest common factor is x minus 1 to the negative 1/2. So that is what I pulled out of the 2 terms, which left me with x plus x minus 1. So here, when I pull the greatest common factor of x minus 1 out of a negative 1/2, out of the 1/2, that left me with just x minus 1 by itself. So if you remember the property of the exponents, because the negative 1/2 would be, if your exponent is negative, it's like a fraction. So your negative 1/2 will end up in the denominator, and this x minus 1 to the 1/2 will end up in the numerator. And when you subtract the 2, you're left with just a 1. That's the reason why we're left with an x minus 1 here. So then we're going to combine like terms. So x plus x is a 2x minus 1. So 2x minus 1 will be in the numerator, and x minus 1 to the 1/2 will be in the denominator. Here's another self-check. I can find the greatest common factor. Factor by grouping. Can factor trinomials. Factor the difference of two squares. Can factor the perfect square trinomial. Factor sum or difference of two cubes. That you can perform the general strategy for factoring, and then factoring fractional and negative exponents. And this is the end of my slide. These are the sources that I used to put this presentation together. If you have any questions or if you need additional help, we are here. Be afraid to contact us through the Learning Center. Thank you.
Awesome. Cool. Thank you so much, Roberta, for that wonderful presentation. And I'll go ahead and post the evaluation now. If you guys have any questions, feel free to ask them in the chat box, or you can unmute yourself if you want to. But here is the evaluation for those that are, whoops, hold on. For those that are keeping track with that, I think there's a couple of students that we have within this presentation. So again, the gift card giveaway, you know, as I've been saying, it's crucial to turn in these evaluations because that's how we're keeping track of, you know, your participation points within these presentations. So this will be counted towards your next one. So right there's the evaluation. Hopefully that's the right one. Let me check really quick. Yeah, sounds right. So yeah, if you have any questions, feel free to ask. And then if not, we can go ahead and end it at that. Our next session at 11, which is starting in 2 minutes, is actually postponed. You know, there is actually a holiday today, so it's the next college day, so that's why it's being postponed. But the other sessions are going to be still happening. So we have one at 1 o'clock with, I believe, Canada. She'll be going over decimals and percentages with Math 102. And I'll be doing a presentation at 3 o'clock with the writing portion. So we'll be going over transitions for coherence. And then all of the other sessions are as scheduled throughout the entire week. So Math 110 was supposed to be beginning today, but unfortunately that one, again, it will be postponed. There'll be a recording of it later on this week, I believe, of that portion. And then, yeah. So does anyone have any questions?